Well, thank you for all coming and sharing your evening with me. I'm very, very excited to be here. My name is Clark Niewendorp. The spelling test is at the end. Niewendorp is Dutch for new village. So, and there are Niewendorps in the Pacific Northwest. So I'm going to talk about LiDAR, light detection and ranging. And this is not, we're not going into the weeds, as I like to say. So this is not really a technical talk. If you can turn the computer on, you can use LiDAR. Okay?
I'm going to close the screen.
So this view is of Mount Hood. It's not mine. It's a 3D perspective view, but we will use that in and out of this presentation. Mostly it'll be 2D, but I like to use 3D too. And by the way, it's not hard to use either.
That bar should disappear.
Nope, you're locked. There, I'll use the mouse. So a little bit of myself. I don't think most of you know who I am, so I went to school in the Midwest and got my master's degree at Western Michigan University in Kalamazoo. Yeah. I was lucky after I got a thesis project in the lead zinc mines in Southeast Missouri and got a job there after school. And this that works, all right. And that was the door to my office at the 1080 level underground. And I worked there 5 days a week. I mean, I like that job, but unfortunately, economy in the 80s. Remember when interest rates were 17%? Yeah, furloughed. Went to a friend of mine started an oil company in South Central Kentucky. Yeah, we drilled oil wells, and we found a few. Guess what happened in the mid 80s? Price of oil went to $15 a barrel. No more work. Gosh, it's been a tough start. Then I went to Florida and got a job in environmental and worked that for quite a few years. And finally, I said, Joyce, my wife's here. I said, I can't do this traveling, and we had a new baby. And so I said, I'm going to try to get a job, and I got lucky and got a job in South Carolina Geological Survey, where I mapped the Piedmont. And for 10 years, I was completely I was overwhelmed first, and this completely didn't know what was going on for 10 years after that. So it was very fun. It was complicated. In 1999, I took my family across. I had to go west. I took them across the Oregon Trail, and I took my family here. As you can see here, this is the part of the Baker Trail, and or I'm sorry, part of the Oregon Trail in Baker County by the interpretive center. And then I got lucky, and this is where this talk is originated. So I got a job there as a cartographer. Got lucky, got on staff. That was my plan to begin with, and in 2018 I retired. In the meantime, look, I'm sorry. I retired as a field geologist, and that was great. In the meantime, I wore quite a few hats, and you're going to see some of the work that I did as I wore those hats. Now, we all have to get into the GIS world. I'm sorry, it's inevitable. If you're going to use this stuff and you're going to use it seriously, I'm afraid you're going to have to do this. It's been the curse. And you know, I'm still doing it 6 years out of being retired. So there's 2 software packages that you can use to help you. It's not to process the LiDAR, but to manipulate it and to make different derivative, images and then derivatives of those images, on and on and on. There's the Esri, which is now ArcGIS Pro. Hey, that's $100 for a license right now. I can afford that. And then there's the free one, QGIS, or I call it QGIS. that is in step with the Esri, and it's free. And it does everything that the commercial stuff does. So classifying LiDAR data. So it comes in a big cloud of hundreds of thousands of points. Even to do an outcrop, which we talked about today a little bit, still will be in excess of 100,000, 200,000 points if we do a really detailed scan. All I care about, and I don't care about the highest hits, which are the treetops. For a geologist, that was always in the way. So all I really wanted and what I looked at was bare earth. And you make a grid, you assign that grid points, the X, Y, Z, three-dimensional, coordinates and an elevation. And you come up with a kind of a detail. I'm pointing to this looks like a dendritic vein, leaf vein. So all that is low points that are black, higher points or higher elevations that are in white, and there's no shading to that at all. So what we like to look at, and what is, what is even a Google map nowadays, is it's got hill shading or on it, or shaded relief for hill shading, whatever you want to do. I looked at those two terms up and they mean the exact same thing. But what happens is there's an algorithm assigned to it, and it says that the sun is going to be up at an angle actually it's going to be in an azimuth of 315, so northwest. It's going to be, the sun's going to be what, at an altitude of what, 45 degrees? Sometimes it's 35, but 45 degrees seems to be the standard. And then you get a preview, then that's like a volcano. And so the sun shines on this side, on the northwest side, and the shadow here is on the southeast, and that's the hill shape. Now you can make, so then you make a raster out of it so we can look at it on the computer, on the screen. And there's different things we can make. We can make it, like I said, a hill shade. Then there's a slope shade raster, which is where we take the elevations of each one of those grid cells, and we compare it to the elevations of the grid cells next to us. We get a change in get a change in slope. I'll show you some of those, some rasters made from that, and you can tell me whether you like that or not. And then we take it a next step further. We can make transparencies, overlays, whole 10 yards here, and create some really stunning visuals. There's one thing I found that the archaeologists use, which I really enjoy using, is that's the sky view factor approximation. It's where pixels look at the sun, it's the sky, and there's a approximation of whether that pixel sees some of the sky, all of the sky, and you can tell if there's holes or ridges. And believe me, that makes a difference in a lot of cases. Spare and fear not. There's a LiDAR viewer. And there's many of them out there. And I happen to use the one that the Oregon Department of Geology and Mineral Industries provides to you free. It is very high quality LiDAR that they put on this viewer. And all you have to do is type in Google DOGAMI LiDAR, and you're right there. A few clicks and you're right there. You just, and I'll give you the pointers up here at the web address if that's what you want to look at. You click on the map. A few other more clicks in there. You got a few, disclaimers and stuff you get into. And then you get this. That's the first, that's a view of, what did we just talk about? We talked about the bare earth. It's a shaded relief. They also provide you with a hill shade, slope shade, and a few other things that we don't care about. Just to point out, this is the Willamette River, and my pointer's going along its course. Right now, let's see if I can follow this spaghetti string. That's the Tualatin River. Oh, where does it go? It goes up. Oh, that's awesome. Oh, Lake Oswego, and this Oswego Lake, excuse me, Lake Oswego right here. You want to go look, this is pretty cool. That's Iron Mountain. Did a presentation on that. But there you go. Oh, why is that star there? Okay, good. That's where we are. So this is LiDAR as we zoom in, how much detail we can get. Oh, so what do we got? The police department, there's the road, Swift Road, there's the stoplight right there. The ponds are right over here behind me. And let's see, I'm parked right there. So that's how detailed it gets. And this is a 1 to 100 scale. We can go down to 1 to 50. So yeah, you can have do a lot of damage with this thing right now. Okay, so I got a question for you. Is LiDAR really the best thing since sliced bread? Well, what can you do with a slice of bread? Well, you can make toast and you can make a sandwich. But look at all the things you can do with LiDAR here. We're going to talk about geology in the next couple slides. I just want to show you what I've done with it. And we're getting into a little landslide mapping and stuff and so forth. So so I use that in my work to do my work. It was a tool. And it really was, well, let's take a look. So the last map that I made for DOGAMI was Brown Creek. I mapped the quadrangle. And if you can imagine, let's see, the Dalles is right up here in the top corner here. So we don't quite see the Columbia River right here. Here's Mill Creek. And I want just to point out that you can really see it. And by the way, this is a 3D perspective. And it's got pretty garish colors on it. Believe me, we didn't publish this map like that. But it helps to show you that although this looks pretty simple, we had really complex area here. This was complex. And then we got to see different things through here. And I think you can still see this as, you can definitely see the stacked layering there. Those are sedimentary beds. And this is what we could do with the LiDAR. So we took the DEM, the digital elevation model, which I failed to really talk about, but that's the grid. Got the elevations and its coordinates. We then used that and did a 3D, we looked at it and said, hey, if we use a 3-point problem, can we automate this to calculate strike and dips? And the reason why this is important is this purple line right through here and this purple line right here. These dips are only 5, 2, 3, 5 degrees. If you take a compass like I did old school and go up there and try to measure that, it's hard. I mean, I can't do it. So we were able to map the stratigraphy, or at least the structural fabric of this quadrangle using LiDAR. The symbols that you see right, oh, there's one in here these are got the little dash line, there's one in here. We used measured areas to help us to calibrate this. Now you see this feature right here? Where in nature do you kind of see those right angles like that? Well, that's part of the government flat fault, or government flat landslide. And it's, gosh, it's nearly 2 miles long and 1 mile wide. I could find this fault in the outcrop and it crossed here. Now here's the story where this stuff comes in handy. What is the chicken and the egg here? Did this fault cause the landslide, or did the landslide cover the fault? In any way, somebody better start asking the question, is there a seismic hazard here? And this is a result of there being LiDAR here in sufficient detail where we could go and see that possibility. So that's where LiDAR really really paid for itself. Yeah. I also did some abandoned mine lands because I was the shepherd of the minerals for DOGAMI. And I'm going to show you an area. Here's Grants Pass, and south of that is near Williams. And I'm going to show you the Humdinger mine. And the Humdinger mine is located over here where the Blue Star is, right in here, this complex in here. This is a topographic map. Now notice that this is the LiDAR viewer, so is that. And you can get topographic maps and other kinds of maps as space maps. So you have that as extras. And we're going to look at this rectangular area and see what we find. So there's a blow up of it. I've got another rectangle in this photograph, the slide as well. But you see all of this disturbance here, if you will. There's no landslides in here. I see stuff like this, and I see these kind of nicks and things. I even see, well, look at this. This is the road. I see the roads here. They're pretty clear, aren't they? Right through there. But I also see stuff like this. They're not so clear, they're subtle. You see something going straight down this hill. What is that? And then there's, I don't know if you can make it out here, but you see a faint line coming to that from across the hill, coming this way. Well, so yes, those are abandoned mine features. Now let me show you the next one. This is what the sky view factor approximation does. You see what it took? It takes that, that's a 1-to-1 overlay. And you can see the roads, and you can see where the ridges are. That's where the berms are and the rocks are. You can see that these black areas here do not see the sun in this case. So those are probably tunnels, pits, or some kind of diggings. This right here, look at that. You really lights up on this one, and that's a hydraulic ditch. That's where they took water to a water cannon, and they started to actually scour out this hill. I don't have the slide below it that shows you actually where the hydraulic workers are. But okay, you still don't, oh, I should mention that these flat areas, now we have to think of those as landings or tops of dumps and waste rock piles that have been flattened out. Okay, now, will that convince you that that's what we're looking at right there? So yes. In the Cascades, where it's that green veil covers everything, this LiDAR will show you where abandoned mine features are. There's 1,500 or 15,000 of them recognized in Oregon. I bet you there's 45,000 when we get done counting them all. Okay, now this is one of the projects I did. This was during the era, and we flew LiDAR in Summer Lake. We also used, also co-acquired TIR data, thermal infrared. And we were looking for geothermal features. We wanted to see if we can find ground that was just a little bit warmer than the ground around it. Maybe that was some indication of some kind of fossil geothermal underground that, well, somebody might be able to drill and find some geothermal potential. So here's what it looks like. We're looking to the north. We're looking at a 3D perspective in this case. And you can see the roads coming through. This is 33, Highway 33. This is Summer Lake. And we can see that these colors, the colors here, this is where we flew the TIR. The darker areas are cooler areas. And the lighter areas, well, this is the lake right here, Anna Lake. But you can see where lighter areas kind of highlight some of the geology. And in this case, we didn't quite find ground that was slightly cooler or hotter than the other compared to each other. But we did find new faults. And those faults now make this there's seismic potential for this area. Go figure, Paisley's down to the south of us, and then we've got Christmas Valley to the north. I mean, if you've ever been to Christmas Valley, you know, there's not many people that live there. And this is what we did find. The TIR does find cold and hot springs, or warm springs in this case. And the only two that are on the maps are this Lost Cabin warm spring and then this Buckhorn Creek warm springs area up here. So yes, there is utility for this right here. Okay, so that's enough. Now, you know, and I know, anyone who works in the field knows that it takes boots on the ground to find it. And to find that bluff at the mist, takes somebody to get out of their car and walk down and look at it. But I'm going to tell you, for somebody who's a novice, let's say I am, can I use LiDAR as a tool to help me find where there's fossil localities? And I'm going to use mist in this case. And wow, who would have figured that I had all this show and tell to help me out to kind of demonstrate it. So here we go. I looked at the literature first, and this is DOGAMI's USGS. I did my Google search. So I found Steer and Moore in the 50s. And let's see, this is a third of a mile. She says that this is a third of a mile from the bridge, or from Mist, south along the river. And Moore said, well, he said, and we can't read it down here, that it's 2/3 of a mile. There's a difference there. How many times have you gotten out of your car and tried to find these localities and say, gosh, I've driven everywhere, I can't find it doesn't work, it doesn't match up. And then Burns et al. In 2005, he showed us a photograph, and he's got a map here, and I'll show you this again too. Okay, now we know. Okay, but I've got clues though from all this work here. I've got actually a picture in 57 or in 53. I've got another picture in 2005. I could start to use this. But what I'm going to really do is I'm going to look at see if they've got published maps, and all publications, the ones I did always had maps. You always had, that was part of the publication. And you always put a map in, and then for paleontology, for looking for mineral deposits and looking for rock hounding and this and that, you never make a real accurate map, do you? You don't want anybody to find these places so they don't loot them. Well, yes. Yeah. So here's so Burns is on the left-hand side. His map, you know, his map's got some points that I can use in the GIS world to help me georeference. And that's a term where I'm going to take this map, assign it control points, and I'm going to lay that on top of LiDAR where it belongs, and what I should say is its position there with geographic coordinates. I've got Steer's map here. You know, this is pretty rough right here too. And then I've got Moore's and Vokes's map right here. And I still got places I can look. This map looks pretty good. In fact, it is. It's the better of the three. And so this program, this is ArcPro, but QGIS will do the same thing. So what I've done here is I've taken it in there, brought it in. This is where you've got to learn some of the secrets of how you work in ArcPro. It isn't easy. And I put control points on the corners where I'm pretty sure I tied it to some geographic point on a map. Can't do it on LiDAR, but you see that behind it, there's a topo map underneath it. So that's georeferencing. So here it is again. I want to point out that on top here, I'm pointing to the control points. But you can see here that we've got a topo map, and I have kind of related it to, and this is the transparency. So it's an overlay now. I'm starting to get, well, yes, this road right here works pretty good. This one is not too bad. These are here pretty well. So this map really works okay. Now I've got this point, and that's where the crinoids locality is put on the map. Still, it's probably off. So let's go check it out. So there's blown up. So I know now there's the river. There's the Burns Bridge. There's mist somewhere. It's up there actually. And so somewhere along here, there's might be the locality. So I'm not going to walk that far. Now I can find it. Here it is on this is overlaid now. This is one of the base maps that you can get in your viewer. And this is, well, look at here. I've got it in this wooded area and understand that that's state property.
State property is actually on the river. Get to the end of Burn Road, there used to be a county right away that went to a bridge across. And the land that there is some
Right.
front plant that been walking across for centuries.
Okay, so now I've got a pretty good idea where I want to go to. I've got to find a place to park. I got to find a way onto this site. You know, I don't want to trespass, and that's what you run into, and I'm worried about that. In my former life, I didn't care about that. When I came to Oregon, I would lose my job if I trespassed. So I try to look for ways to get in. Okay, so here we go. Now, there's that same area. Now we've changed the map here. So this is now a highest hit. This is the highest hit map. Again, we're in the viewer. You see that where I'm pointing to right there. You just click this on right there, the highest hit. And this is the trees, all the vegetation. It includes the buildings. So you can get a good idea of what cultural features are by there, around there. Now, I don't want that. Doesn't do me a bit of good, other than to see that, you know, if I try to take this road, I'm in trouble here. If I try to walk that fence line, I might get away with it, but I probably won't. So let's put the bare earth, the hillshade underneath it. So now I've got a better idea of where to look. And you can see that I've labeled the highway here. Burns Road is right there. Barnhart main line is right over there. Can we start to see different things in this LiDAR? I see the possibility that there's a trail through here. I'm going right down there. Probably have to fall off the bluff to get down to the riverbank though. You might sneak your way through here again and come down here and come up this way. So that's what I look for. Easy ways to get in. Also look to see if there's any features that might be man-made, and I can't see it on this one. So let me switch. Well, before I do that, let me just point out that, you know, granted its shortcomings, I do have a picture. And I do have this little inset map here down here that kind of gives me clues as to what to look for, because I can see that this is a part of a quarry, no? Part of that commercial quarry? It's
I wouldn't call it a quarry. It was just an area
it's a digging, and that's what.
there was a very that the width of this table that was about a meter and a half high, that went for like 20 or 30 feet into the Rizat bed, and it was resisted out and very, very well cemented material.
So I've got, I mean, okay.
But that's long gone. That was gone by 1980.
So we've got some kind of, something that's disturbed here. That's what I would think. Now, maybe we can get a better look at it. And the reason, we can get a better look sometimes if we use a 3D perspective. And I've learned that when I do looking for abandoned mine lands. Sometimes you will not see that tunnel without doing a 3D perspective. There's free viewers to do that, by the way. Esri makes one, so don't despair. Okay. You remember we talked about a slope shade? See the difference? So that's a hill shade. And that's a slope shade. So we're just looking at the change in slope between one pixel and the other, and we get a different look, don't we? To me, this looks like a plastic look. That's what I kind of call it. But I'm starting to see different, look at this. That,
You can see where the
That's-
road came across it, and there was a bridge there.
well, right here,
Well, That's the bridge that's across there, but you see where Burn Road curves down, and you see where it crosses that pasture. And there used to be a bridge on the end that connected, you could see the other connection right next to Highway 47,
Okay.
right where it makes that bend.
Okay.
So
So,
washed out in a big flood, like, nice.
so it's no good now for us to use, but I can really see that indentation that there's a trail or something right there. Another one down through here. There might be a way to sneak in through there. I also see this. You see that? That's a telltale sign that somebody was out there digging. Now, we're going to have to go out there and check it and ground proof it, but I'm pretty suspect that somebody was up here digging on this ledge.
Slide chute that's there.
Well, there's a landslide chute, but
Yeah.
somebody was digging here, and you can really see that somebody kind of notched out here. There might be some workings down and through here, but I also see this. I also see something that is pretty hard. This might be that hard layer you mentioned. No, okay, so we field checked it, but I also see this, that, and that. So there's 3 terraces here that I can map right away. I also see that. There's another quarry up in here. Has that got anything in it? All right. Good place to park, though.
It is.
Okay, so that's what I see in this. Now you combine the two and you get that picture. And I use that sometimes too. So here we are. We're pretty much how, this is how I use LiDAR to find things. I haven't gone into the weeds on how it's made. I haven't, we could have another 3 or 4 1-hour lessons on how to use Arc Pro. We're not going to do that because I'm still learning. So again, there's this this drawing again. I think that it's a pretty good, we're close to right here. So it matches pretty well. So I think, okay, I can go out there and I'm not going to go and I'm not going to get walking and I'm going to get tired. I'm going to fall down some trees and I'm going to give up 100 feet away from where I want to go. And that's what happens when when there's no LiDAR and I was going out and looking for features. So for me, yeah, it's good as sliced bread. So thank you.
So back to the last slide. Right, yeah. So you see where it says the Halem along the river there? That's about the extent of that locality, so it's the width of the Halem.
Right, because this is
It's really at the bottom, 10 meters or.
I understand it right through there.
Now, there's a story about that landslide chute. The owner of the land above on Burn Road was in 1995. He had logged that area, and it actually looks like it's starting to fall apart. Landslide there.
It is right. Yeah, there's the headscarp right there.
Yeah. So
Toe's been removed by the river.
So anyway, pulling pulling all the stuff out. And almost back his rig, the guy across the street, Mr. Epling, saw the back of his tractor, literally right on the edge of the bluff, and he went up there and he went, oh, and they actually had to get larger things and which the thing out of there.
Sure.
They almost lost it. And then the next winter was that when time in which we had all that really heavy snow followed by warm rain, and that's when a huge slide came and almost blocked the river, and it varied the crime rates that are about maybe 15 meters for each.
That's right. That's what happens.
Yeah.
And so you get a good idea of what the geology, first of all, if you're so inclined, and then you can get ways to access this, which is really important in a lot of cases. But I mean, you still have a little bit of a walk, and you still have to bushwhack a little bit through here. So that's how I use LiDAR to find things. And like I said, if you can turn on the computer, you can use this. It's not that hard. Anybody can. It's just a little frustrating at first, but you know, you just got to click on buttons. Right? Right, Garrett? Yeah. It's your turn. Well, that's what I didn't mention. This is a snapshot for 1 instant. And if they don't fly these regularly, and they don't here, this is a one and done. Portland area, for example, they do fly it, and they can do change analysis and do all that. And there's a new LiDAR out for the Portland metro area, I think right now. But since no one really lives out there, and I'm not, you know, don't take me wrong, but the population doesn't warrant continual flights out there. It's just not great enough. Yeah, Aaron?
Traditionally, so the Blackburn Road Park there, and you walk under that terrace, and the trail that angles down to right about where it says river, and then at that point you're on state property, and actually you could cross the bridge and float up the river or down the river, and it's a state big right of way. The big pasture in the front here, while they were doing a lot of extracting of the oil and gas, that thing became dynamic, and it's like suddenly a pond would form, and then it would rise up and stuff. It was pistoning up and down about a meter or two, which is really interesting.
Looks like there's even some dune features in through here.
There are a number of monitors from that property. So
yeah, Aaron. So this is all fixed wing. This was a fixed wing aircraft. You could do it with a helicopter, but this is anywhere from 1,000 to 3,000 foot of elevation. The higher you get, the less detail so they like to fly it as low as possible. This is flown probably at night with no fog, no clouds. And well, I can tell you that one was flown at 5:30 in the morning on the coldest day in January that we could pick, where there was no snow on the ground, where there was no ice either. We were lucky to fly TIR then. This LiDAR here is at a lower quality, only eight hits per meter, where you usually have more 30 to 100 hits per meter. So there's all specs. I wrote the specs for this. We're kind of cheap. Okay, this one had to be flown very carefully because of this. The buttes right here, their plane would crash at 1,000 feet. So this is a little higher too. Portland, this was, oh man, I'm brain dead now. Who's the group? We flew out of Corvallis that did this for us. It was the big group, and I don't know who they've merged with now. And we would So they had multiple planes and they flew up to Burns. That's where they headquartered for this particular project.
Oh, the technology to record is similar to what this reminds me of the detail you get at Cooking Center now, where they have all the different.
Well, I mean, you got an airplane, you've got a laser up there, you've got a couple of computers, you've got ground stations. We've set up ground stations so we knew exactly where that airplane was and where you have to integrate all of that data to make that one pulse have an XYZ coordinate within limits. So you have to know exactly where that plane is. You have to know if pitch and yaw of the airplane makes a difference. So there's a lot of things that's recorded on this. It's really an interesting spec to write. Yes. So this LiDAR will fit on a Cessna, on a helicopter. Yeah.
Are you handling large data files?
Oh, that is the kind of the 1,600-pound gorilla. I mean, at first, DOGAMI tried to handle it and own it all itself. So, ownership is 2/3 of the battle here. And it got to the point where our server farms were getting just overwhelmed. And now they farm it out to somebody else, I think. OSU, Oregon State University, handles a little bit of it too. So no, DOGAMI isn't its sole proprietary. And then we had the forestry try to get in on it. Now that's the Oregon Forestry. They tried to, there was a lot of politics and shenanigans going on with that. So we were part of that consortium, and Oregon started with a $2 million loan that we had to pay back to get this all started when the consortium started.
I had a question about
No, I haven't tried that, but I mean, you have, right?
Yes, I have. Yeah, it worked really great for like doing volumes of stockpiles and stuff.
Yes.
I use them for and doing like trenches and line work and that kind of stuff too. But it would be good for doing context of things too.
Yeah.
The iPhone Pro has a LiDAR module on it, and basically it blasts the object and wraps a photo around that. We do that enough times, and we can create a 3D manifold with high resolution photos of that. So yeah. My company does that. This is my day job, by the way. I would love to find a way to integrate my day job into yeah, as these projects come up or I can find application, man, I'd love to fall into the time. That's pretty cool.
I mean, stuff you could do now is just amazing. So we had to resort to actually structure for motion when I mapped in Burns area, because there was no LiDAR and we needed something better than what the topo maps were. And that would take a photograph, and we had a guy who could do this, and it would generate a decent bare earth DEM for us, and we would map off of that. All right, thank you very much. I enjoyed this. I'll walk out with it, okay?
See. Chat. Here's our option.